Imagine you're building a game like PUBG. You have got players, weapons and scores. But how do you store all that data efficiently? What if you need to add or remove players on the go? Or sort weapons based on the power? That's where Java Collections comes in. Collections give you the powerful tools to store, manage and manipulate data easily. So in this video, we will understand all about collections in Java, what is framework, what is collection framework, and then one by one, we will understand methods of collection framework. Now before we begin, make sure to subscribe to the channel and hit the bell icon to never miss any update. So what is collection in Java? In Java, a collection is like a way to organize and handle a bunch of things like a list of names, numbers or anything else. Instead of managing each thing one by one, a collection helps you group them together and work with them easily. Here are some of the real life examples to make that thing clear. For that, let's first understand what is linked list. Think of it like your browsing history. When you visit a web page, it gets added to the list. If you go back and delete one, the rest of the list stays linked together. It's good when you want to easily add or remove things from anywhere in the list. Alright, so this was about linked list. Next we have is stack. So a stack is like a stack of plates. You always add a plate to the top, and when you need one, you take the one from the top, right? This works in last in, first out way. Whatever you put in the last is the first to come out, like undoing in a game or an app. It's always the last thing you did that gets undone first, right? So this is what about stack. Next one is queue. A queue is like waiting in line at a theme park. The first person in the line gets on the ride first. It works in, first out order. So if you are dealing with things that need to be done in the order they came, like task or customer orders, a queue is perfect for you. Alright, so this was about the collections. Now let's understand what is a framework in Java. So a framework in Java is like a ready-made toolkit that helps you build stuff faster and better. Alright, think of it like building a house. Instead of starting from scratch and figuring out how to lay bricks and set up plumbing, a framework gives you the foundation, the walls and the blueprints. You just focus on decorating and making it your own. That's it. So here's the deal. A framework is pre-designed. It already has a bunch of code, rules, tools ready for you to use. It has functions, classes and libraries, fancy words for things that handle common tasks. So you don't have to write everything yourself. It saves time because you can skip the boring repetitive stuff and get to the straight cool parts of your project. Alright, now let's understand what is collection framework in Java. So the collection framework in Java is like all-in-one toolbox for working with groups of things like list, sets, etc. It's already built into Java inside the java.util package, and it makes handling collections way easier and faster. Here's what it does for you. It is a set of rules and tools like a guide on how different collection types like list, queues, etc. should work together. It gives you interface and classes, basically templates and pre-made blueprints for creating and managing your data collections. It's all connected, so whether you are working with a simple list or more complex collection, they all follow the same style and structure. Now why is it useful? It makes things simple and organized. Instead of writing custom code to store and manipulate data, you can use what's already there. It has efficient algorithms, so sorting, searching or managing large amounts of data is fast and reliable. It's flexible and powerful, whether you need a simple list of items or a complex data structure. The framework has everything for you.
Alright, so now let's talk about methods of collection framework. In methods of collection framework, we'll start with list and slowly we'll move on to other collection frameworks. So in list, so the list interface in Java is like organized shopping list. It's a part of the collection framework and it's perfect when you need to keep things in a specific order and access them by their position. A list remembers the order in which you add things, just like your shopping list. You can add, remove, or update items at any position. Some of the key methods of list interfaces add, get, remove, set, and size. So these methods are used to do the operations. Alright. Now, if you want to use the functionalities of list, we can use array list, and then we have this linked list, vector, stack, which we will be covering further in this tutorial. Alright, so now let's have a look at its code. Now, if we want to use the functionalities of list, we can use array list, linked list, vector, stack, which we will be covering further in this tutorial. All right, so now let's have a look at its code first. All right, so as you can see on the screen, this is the code for list. So let me tell you guys what all the things are here. So if you want to just have a look at it, you can have a look at it and then I'm going to explain it to you. So the syntax is this add function. So basically this add function uses an integer index, as you can see, integer index, and one is the element. So add int index and e element, basically that is the syntax. So basically it adds an element to the list at a specific position. Example, list add, then the position, as you can say, 0 and banana. It puts the banana at the start of the list because 0 is the index in which we want to put the banana. So it puts the banana at the 0th index, which is the start of the list. All right, now then get int index, basically this is the function that we generally use in while doing these operations. Get function, basically inside the get function we basically mention the index, and it fetches the element at a given index. All right, for example, list dot get 1. 1 is the element, so 1 is the index. So basically 1 comes in the second position because it starts from 0 and 1 na? So basically 1 comes in the second position, so it gets the second item. All right, then there is another function which is size. So it basically tells you how many items are in the list. Example, list dot size, it will return 2 if the list has 2 items. As simple as that. I believe you guys understand that. Now this is the basic syntax, so you can see on the screen. So this is how you can add it, and some other functions also I just discussed. So this was about the list. Now let's understand about array list. All right, an array list in Java is like a dynamic shopping cart. Unlike a regular array that has a fixed size, an array list can grow and shrink as you add or remove stuff. It's super flexible and makes managing list of things a breeze. That means it is very easy. So it implements list, that means it's part of the list family. So it keeps items in order and lets you access them by position. You can quickly get or update items using their index, just like arrays. Now, if we want to use functionalities of array list, then these are the methods like add, get, remove, size, ensure capacity. And we have also mentioned, as you can see on the screen, we have also mentioned what all these methods do or the functionalities do. So their functionality is, as you can see on the screen, add. Adds functionality is it basically appends or adds an element to the end of the array list, or you can say inserts it at a specified index if you put the index inside it, inside the brackets. All right. Then there is get. It basically retrieves an element from the specified index if you put the index over there. So it's like that only. So you can just have a look at these. You can because ensure capacity is the new one, so you just know that increases the capacity of the array list. So you can go through all these if you want. You can just pause the video, and we'll be showing you these methods further also. So all you have to do is to I'll discuss as well, but you can also pause it if you want to just read it by yourself. So yeah, so this was about array list. Now let's have a look at its code. All right, so now here's the code for the array list. As you can see, where we have used the list string list because it belongs to the list class. Now here, list string list new array list. So this is basically the syntax. So it basically creates a resizable list of strings. All right. Now list dot add here basically adds apple to the list, as we are just adding an apple string. Then list dot add banana basically adds the banana, and similarly then we will add the orange. Now here we are printing the list. So as you can see, system.out.println, it prints apple, banana, orange. So the array list maintains the order of items you added. So in the same order it will get added. All right, so this was about the array list, and we also just had a look on the methods of it. Now let's understand about the linked list. All right, so linked list. A linked list in Java is like a train with connected cars. All right, so let me just put it in easy words for you. So each car here, car is referring to a node basically. All right, so each car or each node holds data like apple or banana and knows how to get to the next car and the one before it. This makes it super easy to add data anywhere in the list without disrupting the whole thing. Each item or node knows about the one before it and after it. So moving around or making changes is smooth. If you often need to insert or remove items from the middle, linked list is super efficient. Now, if you want to use the functionalities of linked list, then these are the methods like you can see on the screen: add, get, remove, add first, add last. And as we know that add and get, what will it give us, because it is common as of the previous one. And removes here is the new one, so we'll discuss that. As removes, this particular method will remove an element at a specified index. All right, so if you'll mention the index of that particular element that you want to remove and use this function, then it will basically remove that. All right. Similarly, add first is there. It inserts an element at the beginning of the linked list. Add last, as the name depicts, appends an element to the end of the linked list. As simple as that. So basically, the linked list structure is like that, as you can see on the screen. So data is at the center, and it is link previous, previous is basically the link to the previous element, and next next is the link to the next element of it. So it is like that, data and node. So this is how nodes are basically connected in the W linked list, in a collection linked list in Java. All right, so this is how it is. Now let's have a look at its code. All right, so this is the linked list code again. It is quite similar. I believe you guys understand what we are doing here is because most of the operations or most of the methods are similar. In collections, you can say most of the actions are similar, most of the methods are similar, because previously also we used to add apple, because add functionality we have used before, and here also we are adding the same things. So I believe you guys understand what we are doing here. Basically we are creating a new doubly linked list with the help of this one. All right, we are basically creating the new doubly linked list of strings, and then using these we are basically adding apple, banana and orange as the string elements, as you can see. Then basically we are printing it. The linked list keeps the items in the same order you added them. So it is like that. It is the functionality of linked list, that the order in which you have added it, it will keep it in that way only. All right. Okay, so now let's move on to the next, which is vector. All right, so vector. A vector in Java is a resizable and ordered data structure that implements the list interface. It allows you to store elements in a sequential manner, maintaining the order in which they were added. All right. So, one of its key features is that it is synchronized, which means it is designed to handle multiple threads trying to use it at the same time without messing things up. Like an array list, it can grow or shrink as needed. No need to fix the size upfront. All right. So, these are the methods of it: add, and then if you want to, mention the index of it and the element, so basically it will add at the specific position, as you can see on the screen. And add all vector, basically it will append all the elements or add all the elements from the specified vector to the end of the current vector. So these were the methods of vector. And again, let's have a look at its code. All right, so its code is also the same, just we have to look at this part only. So it basically creates a new vector that can hold strings. All right, and then we are basically adding apple, banana, orange. It's up to you. We are just using these three fruits just to just show you how it goes. All right, now just like array list or linked list, the vector keeps the items in the order as we just discussed. Here it's like the thread safe, it is like, which means basically the vector is thread safe, which means it can handle multiple threads trying to access it at once without causing problems. This is great for multi-threaded programs, but can make it slower than ArrayList or single-threaded use. All right, so that is there. All right, so now let's understand stack. All right, stack is there. A stack in Java is like a stack of plates or books. You always add to the top, and when you need one, you take the one from the top first. It follows the LIFO principle, that is last in, first out, which means the last thing you put in is the first thing to come out. All right. For example, if I'll have to give you an example of LIFO, that is last in, first out, you can take an example of bangle. So whenever girls and ladies used to put the bangles on, so the last bangle they have put in will come out the first one. Otherwise, you can't, just take off the first that you put in. In order to take off all the bangles, you have to just, remove the last added bangle. I hope you guys are understanding what I'm trying to say. All right. So in that way, we are trying to convey you that it is basically a LIFO kind of, that is last in, first out. So basically it's built on the vector class. So, it inherits all the resizable and synchronized features of vector. It is designed for tasks like you want to add or remove things in a last in, first out order. For example, as you can see on the screen, you can push it and then pop it from the last itself. You're putting it from the last, pushing it, and then if you want to remove it, it will get removed from the last place itself. All right. So yeah, so these are some of the methods. So as you can see on the screen, push, basically push adds an element to the top of the stack, and pop removes and returns it all as well, the element from the top of the stack. So peek basically retrieves the element but not remove it of the top of the stack basically. So for example, let's say 1 2 3 4 5 6. So the lowest one is having 1, then 2, then 3, then 4, then 5. So peek will retrieve that but not remove that, whereas pop will remove that as well. Okay, so this is the difference between peep and pop. Very simple. And then there is empty. It basically checks if it is empty. This method. All right. Then search is there. It returns the one base position of an element from the top of the stack or -1. It is not that important, but you can just have a look at it if you want. All right. So now let's have a look at its code. All right, so this is the code for stack. As you can see on the screen, stack, string, stack, new stack. This is basically the syntax of it. I believe you understood the syntax because it is almost the same and operations are also almost the same. But here, instead of add, we are using push. So basically, stack, this particular syntax I'm talking about right now. This particular syntax is creating a new stack to hold the strings. All right, after that we are just using it and pushing the elements inside it. So one by one we are doing that. Stack dot push apple, it basically adds apple to the top of the stack. Then stack dot push banana, it adds banana above it. Then orange goes above it. So it is like that. Orange on banana it will go. So pop of the top item, if you want to pop it. So this is what we are doing right now over on the screen. System.out.println, we're printing it and we are popping it. So basically, as I told you, pop will remove it. Okay, so it will remove and print the top item, which is orange. After this, banana becomes the new top. You understand? It was like apple, banana, and then orange. So when we did stack.pop, it basically removes the orange, and now the topmost element which is remaining after removing orange is banana. So now banana becomes the new top. All right. Okay. So I hope you guys understood this part. It is pretty easy. Now moving on to the next, which is queue. All right. Queue is there. So a queue in Java is like waiting in line for tickets or food. The first person to get in line is the first to be served. It follows the first in, first out principle, that is also known as FIFO principle, which means the first thing you add is the first thing you take out. It's an interface, so you can use classes like linked list or priority queue to create a check. Perfect for managing things within the order that matters, where the order basically matters the most, like customer service or task scheduling. All right, so you can just have a look. Basically, the queue of, if you're going for a want to watch a movie or something, you stand in a queue one by one. And if you want to buy a popcorn or cold drink or something during the movie, you have to stand in a queue line, right? So whenever your turn will come, then only you'll be able to make a purchase out of it. So that is how, that's exactly what queue is. So whosoever goes in first will be will be removed first. For example, if I have to give you another example of it, then it is you can take an example of toll barriers that we encounters while driving. So the first car will go first, and after that the second car will pass out from that. That the last car is passes the first. It is not like that. You can take a fine example of toll barriers here. The first car will go, then the second car, then the third car. All right. So I hope you guys are understanding. First in, first out, which means the first thing you add is the first thing you take out. It is an interface, so you use classes with linked list or priority queue, so which we'll discuss further prior to queue, to create a queue basically. Now, perfect for, it is basically perfect for managing things where the order matters, like customer service or other task scheduling activities. All right. So I hope you guys understand that. All right, so these are the methods that is on your screen. This is the methods that we can use on queue. Add is there. Add is not a new one. We know poll also. We know remove also. Peek we also know. So it is same as that of the previous ones. But here the new one is offer. So as we can see, we have offer. So offer basically inserts an element into the queue, returning true if successful or false if the queue is full. All right. Simple as that. Basic English we have written. So you can also understand that thing, what I've just said. All right. To make you guys understand it in a better way, so let's have a look with the help of an example. So let's move on. All right. So as you can see, this is example of queue, and we have used queue.offer. So this is the method that we just discussed. So basically, this particular, again, I'm telling you, this particular thing that we can see, it is creating a queue using a linked list. All right. Basically, we are creating a queue using a linked list. After that, we are basically adding the items. Queue.offer apple. Now, it basically adds the apple to the queue, then adds banana to the queue, and then adds orange, like that only. Now, poll the first item if you want to, then poll is here. All right. So, poll, as we know, it removes and returns the first item. For example, in this case, the first item would be apple because we have put in the apple at the first time. All right. So, it is opposite of LIFO, LIFO. This is FIFO. The first that goes in, it will come out the first. The first that goes in, the first, and that is the one that will leave first. Okay. So, apple would be the case here, you know. So, in this case, apple, will be removed first. After this, banana becomes the first item in the queue. Then, yeah, so it will go like that. Then we can see another peak is there. So basically q dot peak. So it basically looks at the first item, banana, without removing it. Okay. So if we have removed apple, then the first item will become banana. And basically it will have a look at it and it will, retrieve it or print it, but it will not remove it. Okay. So simple. All right. Now moving on to priority queue. So priority queue. So priority queue in Java is like a to-do list where the most important task gets done first. Unlike a regular queue, which follows FIFO, that is first in, first out, a priority queue processes items based on their priority. Items are not processed in order they are added, but based on their natural order. You can use it like any other queue, but with priority-based behavior. Some of the methods used in priority queue are as follows. Add is there, offer is there, remove is there, size is there, and clear is there. Clear is the new one, so let's have a look at it. Remove all elements from priority queue. So if you want to remove all elements from the priority queue, then you have to use clear. And I believe you guys understood about priority queue. It is a bit different from queue because it has this priority wala thing. So priority, it gives the most important task basically gets done first in priority queue. All right. I hope you guys understood this thing. Now let's have a look at it with the help of a fine example. All right, so this is the priority queue example. Okay, so as you can see, it is pretty much same as that of queue because it is actually the same. But the only difference is ki here also we are creating a queue use that prioritizes smaller numbers. All right, so we have used here the priority queue. As you can see, we are not using linked list, but priority queue here because it basically here what we are doing is we are creating a queue that prioritize smaller numbers. So for that, it is like that. This is the syntax of it. Then queue dot offer 5 to basically we are adding 5 to 8. Now adds basically all of these are we are adding it. All right. Now poll the highest priority item. So as you can see on the screen, the highest priority item will poll it. Basically, will remove it. So it removes and returns the smallest item, that is 2. As we know that q.poll will remove and return the smallest item, that is 2 over here. So it will do that. All right. Then peak at next priority item, as you can see, peak is there. So q.peak, look at the next smallest item, which is 5 now. After 2, there is 5 now, which is the next smallest item without removing it. So in this particular case, it will not remove it, but it will, retrieve it or access it or print it, you can say. All right. Now moving on to dequeue. So a dequeue, short for double-ended queue in Python, is like a flexible queue where you can add or remove items from both ends. Imagine it as a train with open carriages where passengers can hop on or off at either the front or the back, depending on their convenience. It works like both a queue, that is FIFO, and stack LIFO, depending on how you use it. All right, so these are some of the methods that we basically use. Poll first removes and returns front element, all right, and poll last removes and returns the end element. Similarly, add first adds to the front and add last add to the end, all right, and remove first also removes and returns the front element, and remove last also removes and returns the end element. I hope you guys understand this. Now let's have a look at the. All right, so this is an example of Dequeue. So here, as you can see, Dequeue string Dequeue equals to new array Dequeue. So it creates a new Dequeue. Basically, this is the syntax of it. Now, Dequeue dot add first over here, we are adding apple. So it basically adds apple to the front of Dequeue. Then Dequeue dot add last, and then we are adding banana. So it adds banana to the end because here we have used add last. Then Dequeue dot add last orange. It adds orange to the end. Now, Paul, as we know, Paul will, removes and returns the first item, apple. So apple will get removed. And it will also, it will print that and remove that. Paul first. It removes and returns the first item. Apple will remove and it will return also. Then peak is there, as you can see, peak last is there. So dequeue.peak last looks at the last item, orange, without removing it. So it will not remove orange, but it will return it. Alright, so this was about dequeue. Now let's understand set interface. So the set interface in Java is a part of java.util package and represents a collection that does not allow duplicate elements. It models a mathematical set abstraction, ensuring that no element is repeated within the collection. The set interface extends the collection interface and provides the foundation for various set implementations. It's the part of Java collection framework, so it works like other collections but with its unique rules. All right. So these are the methods that we use in sets, that add, remove, clear. Clear is new, so it removes all the elements from set. Then contains basically checks if the set contains a specified element. So you can put an element and then it will check if it is there, it contains that element or not. All right. Then size is there. I believe you understand what size is. Then is empty. It basically checks if the set is empty or not. All right. Now let's have a look at its code. All right, so this is the example of set interface. So as you can see on the screen, set.add will add apple. But before that, let me tell you set string set new hash set. It basically creates a set of strings. All right. Then set.add apple adds apple to the set, then adds banana, then adds orange. And as you can see here, again we have added set.add apple. It tries to add apple again, but since it's already there, the set ignores it because set doesn't take the duplicate values. All right, set only takes the unique values. So basically it is already there, so basically it will set will ignore that, you know this particular thing. Now, the time to print it, system.out.println set, it prints something like apple, banana, and orange, but it will not print apple again, as I just told you. It will not, print apple twice, only unique values. All right. So order may vary since hash set doesn't guarantee order, but yeah, it will guarantee unique values. Okay. So that is there. Now, come on, let's move on to the next thing, which is hash set. Alright, so hash set is there. A hash set in Java is like a magical bag that only allows unique items and doesn't care about the order. It uses a super efficient hash table under the hood, making it super quick for adding, checking, or removing items. The order of element isn't guaranteed, items are sorted based on their hash codes. Alright, so this is that simple. Again, here are the methods that we generally use: add, remove, clear, contains, size, is empty, and you know all the functionalities of all these one. If you just want to learn again, have a look at it, just you can just pause this video and have a look at the functionalities of each of these methods. Now let's have a look at its code now, hash set. So as we thought that it will be as same as that of the previous one. All right, so we are creating a hash set of strings. All right, here we are creating a hash set of strings, and then we are adding apple, banana, and orange, then we are printing it. So it prints something like banana, orange, and apple only. The order isn't predictable because HashSet doesn't maintain the order. But yeah, again, all things else will be unique. So yeah, it is same as that of the previous one. Now coming to the linked hash set. The linked hash set in Java is a concrete implementation of the set interface and is a part of the java.util package. It combines the features of a hash set and linked list, ensuring that the elements are both unique and ordered based on the order in which they are added. This makes it a predictable and well organized alternative to a regular hash set. It keeps track of order in which items were added, so when you iterate over it, the items come out in the same order. All right. So these are the some methods of it. So as you can see, add adds the special element to the set if it is not already present. All right. Clear removes all element. Clone returns a shallow copy of the linked hash set instance. Then contains, it returns true if the set contains the specified element. Then is empty, though we know already, right? So yeah, the example part would be the same as that of the previous one, no nothing. But over here we will just use set string set new linked hash set. Like previously we were using, for the previous case we used set string set new hash set, but over here we will use set string set equals to new linked hash set because we are creating a linked hash set this time. So that only will be the change. Others, like other operation, would be same as that of the previous one, so we don't need to really worry about that. And that creates a linked hash set for strings, and then we'll simply add that. And the order is same as the order in which the items were added in this particular case. All right, the order will remain same in which we have added. The order will be is of that itself, that order itself. All right, so now let's discuss sorted set. So a sorted set in Java is like a special kind of a set that automatically sorts its elements. So not only does it keep the items unique, but also keeps them in specific order, either in natural order, ascending order, or a custom order you define. It includes methods like first to get smallest element, last to get the largest, and subsets like head set and tail set. These are some methods, and some of the other methods that are on the screen. As you can see, it is same as that of the previous one, but some of the methods, example that I just told you, that last is there, then headset is there, and tail set is there, that you can also explore those methods. It is simple as that. I mean, if you just have to try those methods on your own basis. All right, it is very simple. You don't need to worry. All you have to do is apply those methods and just read about it, because there are very, long list of methods that you can't remember all those methods. You just have to go through it, and the most frequent repeating ones you will be able to remember. All right. Now let's have a look at its example. All right, so as you can see on the screen, first of all, here we are creating a sorted set. So basically we are creating a, what we call a tree set, you can say. We are creating a tree set which implements sorted set interface. All right, so now using set.add, we are adding apple, banana, then orange. Then while printing, the elements are automatically sorted alphabetically. So this is the case in this one. The elements are automatically sorted alphabetically. All right. Now coming to the next part, which is TreeSet. So TreeSet in Java is a part of java.util package. It is a collection of unique elements that are automatically sorted in ascending order. Unlike HashSet or LinkedHashSet, which don't sort elements, a TreeSet ensures that its elements are always sorted in a natural or custom defined order. It provides methods to navigate through the set, such as finding elements lower, higher, ceiling, or floor relative to the given value. And some of the other methods are just mentioned on your screen. You can have a look at it. Add all is there, clear is there, clone is there, comparator is there, contains is there. So these are the methods. Some of the more methods are there. You can, just have a look at it on Google, and you know, the most frequent one are the ones that I'm just showing you on the screen. Other also is there. You can just have a look at them as well. All right, so now let's have a look at this example also. So this is an example of tree set, as you can see. So this part is basically, as you can see, let me just highlight this part. So it creates a tree set to store strings, all right? And then again, we are adding apple, banana, and orange as we were doing earlier. Then we are printing it, and the elements are sorted alphabetically, all right? And when we'll print it now, so the elements will be sorted alphabetical order, all right? So basically, tree set will take care of that thing, all right? All right, so now let's have a look at advantages of collection framework. The collection framework in Java is like a treasure chest of developers. It gives you all the tools you need to handle data easily, efficiently, and consistently. So the first advantage is consistent API. The framework provides a standardized set of interface like collection, set, list, and map. This means every class that implements these interfaces follow a common set of methods.
For example, whether you are using an array list or a linked list, you will have methods like add, remove, and size. Why it's great now? It makes your code reusable, easier to read, and simpler to work with, since you don't need to learn a new way for each collection type. Alright, the second advantage is reduce programming effort. With the collection framework, you don't have to reinvent the wheel. All the hard work like designing and implementing data structure is already done for you. You can focus on how to use the collections in your program rather than worrying about how they work internally. Alright. Now, why is it great? It supports the principle of abstraction in object oriented programming. Your code becomes more maintainable and easier to understand. Third advantage is improved program speed and quality. The framework includes high performance implementations of commonly used data structures and algorithms. These implementations are optimized for speed and efficiency, so you don't have to write your own algorithms to handle tasks like sorting, searching, or managing large data sets. Now, why is it great? Like, it leads to faster programs with reliable results while saving you time and effort. Now, let me ask you this. If you want to become a cloud professional and advance your career in one of the fastest growing fields, the professional certificate program in cloud computing and DevOps is for you. This online program is designed for working professionals, providing practical skills and knowledge needed for cloud and DevOps roles. You can opt for additional AWS or exam preparation for an extra fee. Whether you're starting fresh or leveling up, this program will help you take your career to the next level in cloud computing and DevOps. So don't wait, click the course link in the description to learn more. And that's a wrap on Java collections. Whether you need a list, a set, etc., collections make handling data super easy. In this video, we covered various methods of collection framework like linked list, vector, stack, queue interface, and much more. If you want, you can go through the video again to understand the concept again. But do try these concepts on your own. Now, if you have got any questions, drop them in the comments and we will be happy to help. Don't forget to like, share, and subscribe for more Java content.